Morning students. Today we will start with last unit of our paper CCL 105, that is alkynes. Alkynes, that means also unsaturated hydrocarbon which contain carbon-carbon triple bond. So general formula of alkynes is CnH2 -2. Alkynes are isobaric with dienes. Dienes means those compounds which contain two carbon-carbon double bonds. Now, nomenclature of alkynes. In common system, alkynes are named as alkyl acetylene. So some of the compounds have special name. This is simplest alkyne known as acetylene. Now this second compound, this is 4 carbon containing compound, is named as derivative of acetylene. So this part is from acetylene, and name of this compound is ethyl acetylene. Similarly, the compound this compound is known as ethyl acetylene. So in common system, alkynes are named as alkyl acetylene. In IUPAC system, suffix "-wine" is used in place of "-ane", as in case of simplest hydrocarbon alkanes. Find the longest chain containing triple. In alkanes, we name the compound by choosing the longest chain containing double bond. Similarly, in alkynes, we choose longest chain containing triple. Number the longest chain in such a way that carbon-carbon triple bond gets the lowest number. This 4 carbon containing compound is known as alkane. Now, this is alkyne unsaturated hydrocarbon. If we start numbering from this side, lowest number is 2. If we start numbering for this side, number of carbon containing triple bond is 2. So the name of this compound is 2-butyl. Similarly, 6 carbon. This is a 6 carbon containing compound, and if it is saturated, then it is known as hexane. Ane of hexane is replaced by -wine, as it is an unsaturated hydrocarbon alkyne. And numbering is done in such a way that carbon-carbon triple bond get the lowest number. So we start numbering from this side where carbon gets lowest. The name of this compound is 2-hexyl. Right, so by naming the alkynes, locate and name, attach, group, and at last finalize all the name of all the substitute. Name of this compound in this compound, one substituent bromine is present. Numbering is done in such a way that carbon-carbon bond triple bond gets lowest number. Numbering is done from this side: 1, 2, 3, 4, 5. Name of this compound is 5-bromo. 5 carbon containing compound. So pentane. Ane of alkane is replaced by -wine. So 5-bromo to pentane. The second compound, numbering is done from that side where triple bond gets lowest number. So 1, 2, 3. 2, 6 dimethyl, 7 carbon compound, heptane. So the name of this compound is 2,6 dimethyl 3-heptane. Similarly, double and triple bond is present. If both double and triple bond is present, numbering is done in such a way that this double bond gets lowest number. So 1, 2, 3, 4, 5, and 6. Name of this compound is methyl, 1 hexene, 5 yang. The main functional group is OH. So numbering is done by giving the lowest number to main functional group. Numbering is done for this at 1, 2, 3, 4, 5, 6. 4 hex wine 2 O. Yeah, hex 4 wine 2 O. So while naming alkynes, first choose longest chain containing triple bond, then locate the substituents and number this substituent according alphabetically. If main functional groups are present, then functional group gets priority over the multiple bond. These are the alkynyl group. If this group is present as substituent, then known as ethanol. If this group is present as substituent, then known as propane. Classification of alkynes. Alkynes are classified as terminal alkynes and non-terminal alkynes. As the name indicates, terminal alkynes are those compounds, those alkynes in which triple bond is present at terminal position, that is at the end of the chain. While non-terminal alkynes are those compounds or those alkynes in which triple bond is present somewhere in between the chain and not at the ends. Like alkenes or alkanes, alkynes also show structural isomers. Structural isomers are those isomers in which molecular formula is same but arrangement of atoms or groups is different. First is chain isomers. One compound is straight chain in which carbon chain is present in straight form, while in other form carbon is present in transposition isomerism. As name indicates, position of triple bond is present at different position. In 1-butyne, triple bond is present at first position. In 2-butyne, triple bond is present at second position. Functional isomerism, as already told you, that alkynes are isomeric with dienes. In alkynes, triple bond is present, while in dienes, double bond is present. So, in one compound or one isomer containing triple bond, other isomer contain double bond. So, the alkynes also show functional isomerism. And last is ring chain isomerism. One isomer is present in straight form, while other isomer is present in ring form. So, different type of isomerism shown by alkynes are chain isomerism, position isomerism, functional isomerism, and ring chain isomerism. Structure of alkynes. Alkanes are sp3 hybridized, alkenes are sp2 hybridized, while alkynes are sp hybridized. In sp hybridized, one sp hybrid orbital overlaps with 1s orbital of hydrogen or 2s orbital of carbon to form carbon-hydrogen or carbon-carbon single, while other hybrid orbital form carbon-carbon single bond with sigma bond with other carbon atom present in the molecule. The remaining unhybridized 2 orbital left over each carbon atom overlap sidewise to form electron club. Structure of alkyne is linear and bond angle is of 180 degrees. In this structure, here we show carbon hydrogen. This is simplest alkene, that is acetylene, in which carbon hydrogen sigma bond is present. Carbon hydrogen sigma bond is present, which is formed by overlapping of hybridized orbital. Similarly, carbon-carbon sigma bond is present, that is also formed by overlapping of sp hybridized orbital. The two blue blue bonds show pi overlapping between unhybridized p orbital of two carbon. This is the orbital picture of ethyne. Here a carbon-carbon pi bond formed by overlapping of unhybridized p orbital, a carbon-carbon sigma bond, and carbon-hydrogen sigma. Now next is method of preparation of alkynes. Alkynes are prepared by dehydrohalogenation of vicinal and geminal dihalide. Vicinal dihalide means halogens atom present at adjacent carbon atom, while geminal dihalides means halogen atom present on same carbon atom. Dehydrohalogenation means removal of hydrogen and halogen from the same molecule. When alkene, this is geminal dihalide, and this 2,3-dibromobutane is vicinal dihalide. When these dihalides are treated with strong base, they abstract hydrogen and remove trans halogen atom. So loss of HBr and HBr, 2 times loss of HBr takes place, which results in the formation of alkynes. This is the mechanism of dehydrogenation. As sodamide is strong base abstract hydrogen as H negative, and a carbon hydrogen shift between carbon and removal of Br negative take place. So double bond is formed by removal of HBr. Now so base again attack on hydrogen atom, and similarly again loss of HBr take place, which result in formation of alkynes. First dehydrogenation can be readily achieved by weaker bases like NaOH. The first step is easy, while second dehydrogenation requires strong base like sodamide in liquid form. Next method is dehalogenation of tetrahalides. Tetrahalides means molecule containing 4 halogens, and dehalogenation means removal of halogens. So when tetrahalide treated with zinc, loss of zinc bromide take place, and we get alkynes. In this case also, here removal of reaction take place by E2 mechanism, attack of Zn, X2 का loss हो जाएगा, फिर attack of Zn, फिर X2 का X का loss हो जाएगा. This reaction takes by E2 mechanism and we get alkynes. Next method is laboratory method is action of water on calcium carbide. Calcium carbide is prepared by treating carbon with calcium oxide, which form calcium carbide and carbon monoxide. When calcium carbide is treated by hydrogen, it results in the formation of acetylene plus calcium hydroxide. Higher alkanes can be paired by removing terminal hydrogen with strong base like sodamide, and the acetylide ion thus formed is reacted with alkyl halide to form long chain alkynes. H positive can be removed as terminal alkynes have acidic nature, so H positive can be easily removed by treating it with strong base to form sodium acetylide. Acetylide ions are two nucleophiles. When these acetylide ions reacted with alkyl halide, it undergo SN2 reaction with primary alkyl halide and form long chain or higher alkynes. Here, acetylide and negative ion of C negative attack at CH3 and loss of I negative take place. In this way, we can increase the length of alkynes, chain length of alkynes. Here, in this case, backside approach is not possible or hindered. So, this reaction does not take place by SN2 mechanism. This is secondary bromide. In reaction of acetylide ion easily take place with primary halide. However, if secondary halide is present, backside attack is difficult. So, in this case, reaction takes place by E2 mechanism in which acetylide and abstract hydrogen from methyl group and this butylide and form butane, while this isopropyl bromide form propene. Physical properties are similar to alkanes and alkyne. These are also non-polar in nature, insoluble in water, soluble in non-polar solvent, less dense than water, and have low melting and boiling point. This is for today. In next lecture, we will discuss about chemical properties of alkynes. Thank you.